So today we will be looking at the microphone comparison, because yesterday we have seen the various types of the microphones. Okay, so today we will have a quick uh, review of the comparison of the microphones. Okay, so basically, on which factors you are going to compare the microphone, right? That is the question. So you you must know what is the sensitivity of that particular microphone. Okay, what is the frequency response of the microphone, what is the distortion, percent of distortion. Okay, then directivity pattern, output impedance, effect of temperature and humidity, DC bias supply, and for what application it is used. So you need to consider all these factors in regard with the microphone. Okay, so now till date we have seen five types of microphones. Okay, the first one was carbon. Shreyas, please mute your audio, and Tejaswini also, so that background noise should not be there. Okay, please mute your system so that you can hear properly. Okay, the first one was carbon, the second one was moving coil. Okay, third one was crystal, fourth one was condenser, and fifth one was ribbon. Okay, so these are the category of the microphones. Okay, so we have to compare all these microphones with reference to these parameters. Okay, so now considering the sensitivity, right from 1 to 5 the sensitivity gets decreased. Okay, the frequency response, coming to the frequency response, the carbon is having 50 hertz to 5 kilohertz, moving coil is having 50 hertz to 8 kilohertz, crystal 80 hertz to 6.5 kilohertz, condenser 40 hertz to 15 kilohertz, and ribbon 20 hertz to 12 kilohertz. Okay, so now you can look here that basically the audio frequency range is 20 hertz to 20k. Am I right? The thing is that there is no, ideal microphone. There might be, but still in practical use you cannot have this precise, frequency response. Because what happens, there are certain frequencies nearly 20 hertz to, let us say, 30 hertz, and for example 19 kilohertz to 20 kilohertz, which is very difficult to listen to the user. Okay, though we are having the upper value and lower value, but the middle part of that particular thing can be audible for us. So you can see most of the frequency responses of various microphones are lying within 50 hertz, okay, to 12 kilohertz or 15 kilohertz, like that. Understood? Okay, so the distortion for that particular microphone. Okay, so right from 1 to 5 the distortion becomes very low, right? Right from the carbon, moving, crystal, condenser, and ribbon. Okay, the distortion is very very low, because for carbon it is high, for moving coil it is low, for crystal, condenser, and ribbon it is very low. Okay, then coming to the next comparison parameter, that is directivity pattern. Okay, so basically most of the microphones right from 1 to 4 are omnidirectional, and the ribbon is bidirectional. Okay, then coming to the output impedances. Okay, carbon is having moderate, nearly about 150 ohm, moving coil is having a low impedance, that is ranging from 30 to 100 ohms. Crystal is having a higher 100k. Condenser is having larger impedance 100 mega, and this ribbon is having very very low, about 0.25 ohm. Okay, so coming to the effect of temperature and humidity, only carbon and crystal can be affected by the the environmental parameters like temperature and humidity. Okay, then coming to DC bias supply. Okay, so uh, for carbon and condenser, they require the external DC bias supply. Others like moving coil, condenser, and ribbon, sorry, the carbon, the moving coil, the crystal and ribbon are not required DC bias supply. Okay, and coming to the applications, the carbon type of microphone is used in the telephones and portable handsets. Moving coil type microphone can be used for PA systems and so on. Crystal type of microphone can be used for home recording or mobile applications. Condenser type microphone is used for the calibration as well as recording in the studio. And ribbon type of microphone can be used for the dramas and studio recording. Okay, so in this way you have to compare all the microphones with reference to the mentioned parameter. Okay, so for further reading, there is a very nice website which is only meant for the microphones and their technicalities and various aspects. Okay, so this is the website mynewmicrophone.com. Okay, so in that website you can find all the details. Okay, the comparison which I have just mentioned. Okay, then few more technical parameters. Okay, and further reading can be explored by means of this website. So you just note down, and after this lecture you can surf and find out the relevant contents regarding with the microphones itself. It is exclusively for the microphones. Okay, then the thing is that what is the requirements of a good microphone? Okay, so these are the basic requirements for the microphone. Okay, based upon for what purpose you are using that particular microphone. Okay, so the first requirement is the microphone must have high sensitivity. Okay, because low sensitivity gives you various issues while recording or while amplifying that particular sound. The flat frequency response over desired frequency range. Okay, so you must have a flat frequency response for particular range. And just we have seen a particular microphone, let's say, having a frequency response within 80 hertz to let's say 15 kilohertz, right? So it must have flat frequency response within this range, because if the response is not flat, then you may face some kind of issues at the time of amplification and you know at the loudspeaker side, at the output side. Okay, then the third and important parameter for the requirement is proper impedance matching. Okay, so impedance matching is done for the maximum power transfer. Okay, so you need to understand which methodology you are going to use for matching the impedances. Okay, so you must know the resistance detail or impedance details for the loudspeakers as well as microphone as well as the PA system. Okay, including the amplifiers and mixers. Okay, the fourth requirement is directional response as per the need of application. Okay, so here as per the need of application you are going to choose what kind of microphone is suitable for us. Okay, so if we are dealing with certain recordings like musicals and so on. So at that time, okay, what kind of microphone that you need to do, sorry, that you need to use, okay, whether you are going with a ribbon or whether you are going with moving coil, that you have to finalize. And if you are having one-to-one recording in the studio, like generally it is practiced in the, you know, on the radio broadcasting and so on, at that time I must use the condenser microphone and so on for having a clear sound, okay, because that is having a greater response regarding with the application, okay. Then the SNR must be high, and finally we must have very low distortion, okay. So in market you can find various types of microphones, okay. So noise cancellation microphones are there, but it requires some add-on for that. But still, it can be used to reduce the, the ambient noise which is present in the scenario where you are performing the recording. Okay, so these are the requirements for a good microphone. Provided that you must know for what purpose that uh, microphone is being used. Okay, then coming to the special microphones. Okay, there are again various types of microphone for special purpose. The first one is lavalier, the tie clip, wireless, noise cancelling, water microphone, shotgun type microphone, fiber optical microphone, digital interface microphone, laser microphone, and MEMS microphone. Okay, so lavalier and type tight clip. Okay, so you must have found these in the conference hall where uh, the speaker is continuously moving, okay. So these are the type of a collar mic, okay, clip mic, or you can say collar mic, okay. So lavalier microphone or lavalier, also known as lapel mic, clip mic, body mic, collar mic, neck mic, or personal mic. It is a small microphone used for television, theater, and public speaking application in order to allow hands-free operation. Okay, so that you have seen. And in this regard, the second is also like that. So this is the tie clip microphone, in which interface is connected to the system by means of this 3.5 mm jack. Okay, and there is a system which wirelessly transfers uh, your audio signals, okay, to the public address system for further amplifications and so on. Okay, so the third category wireless microphone that we have seen earlier in the yesterday's lecture. The fourth one is noise cancelling microphone. Okay, so what is noise cancelling microphone? Noise cancelling microphones are a great addition to any PC setup, as these plug and play peripherals can produce studio level sound without needing a professional mixing board or analog equipment. Okay, so for that purpose, you need some PC setup, right? So as to reduce the ambient noise and so on. Okay, so these are the noise cancelling microphones. Okay, then water microphone. Okay, so a water microphone or water transmitter is based on simple principle Ohm's law, that current in a wire varies inversely with the resistance of the circuit. The sound waves from a human voice cause a diaphragm to vibrate, which causes a needle or rod to vibrate up and down in the water that has been made conductive by a small amount of acid. Okay, so that is the principle of working of this water microphone. Okay, Then coming to the shotgun. Okay, basically, shotgun type of microphones, you have seen in the what we can say, this movie recording or some, live coverage or film recording. Okay, so it is having such handles. A person is keeping that rod, okay, like this, and this is your shotgun type of microphone, and other person is speaking and other person is recording, okay, the scenario. Okay, so such type of microphones are generally called as shotgun type of microphone. Okay, then coming to the fiber optic microphone. Okay, so in this, the sound is converted into changes in the light intensity. Okay, a small reflecting diaphragm is illuminated by laser light produced by the laser LED, which is guided through an optical fiber to the diaphragm. Okay, due to sound waves, the diaphragm vibrates and the laser gets reflected accordingly. The sound waves are converted into variation in the laser intensity. Okay, and finally, the laser beam falls on photodiode, which converts the brightness variations into electrical signals. So the same concept is used as we have seen in the optical disc recording. Okay, so instead of that particular electric sound, we are converting the sound energy into the variation of the LED light intensity, and then the photodiode is used for conversion of that varying intensity of LED into electrical signals, right? Okay, then digital interface microphone. Okay, it is having built-in digital interface, okay, provided along with the microphone to produce direct digital output, which is proportional to the sound. Okay, so here we require a lot of assemblies, okay, to convert the sound into electrical signal. But as far as the digital interface microphones are concerned, here the sound waves are directly converted into digital output, so that particular assembly is associated with such kind of microphones. Okay, so typical application of such microphone is the digital hearing aids machine. Okay, they use small microphones using crystals followed by the digital interface to produce the sound in the digital form. Okay, and coming to the next one is laser microphone. Okay, so this laser microphone is a surveillance device that uses a laser beam to detect the sound vibration in a distant object. It can be used for various applications. Okay, so here basically it is a surveillance device. Okay, we can use the glass window of the room to record the sound originating near the window. Okay, the laser beam is incident on the glass window or any other similar plane of glass near the sound source. Okay, and the reflected laser is incident on the photocell, okay, or photodiode, which is acting as a detector, and the output of the photocell is applied to an amplifier, loudspeaker, okay, to amplify the sound. Basically, some sound sources are coming, okay, sound energy is coming. uh, Before that you have to put the glass, okay, and some laser source is reflected, okay, is pointed to the glass window, and reflected laser is applied to the photocell, and which photocell will convert that particular variation into electric signal, which is then applied to the amplifier and then to loudspeaker. Okay, the next type and final type is the MEMS microphone. Okay, so what do you mean by this MEMS microphone? MEMS stands for micro electromechanical system. Okay, so these types of microphones are also called as microphone chip or silicon microphones. Okay, MEMS processing techniques are used to catch out a pressure sensitive diaphragm directly into silicon. Okay, so most MEMS microphones are the types of a condenser microphone. Okay, that there are digital MEMS microphone as well as uh, some which are having built-in analog to digital converters. Okay, so which is having a very precise size and precise sensitivity. Okay, so that you can use for a special purpose. Okay, by using this MEMS microphones. Okay, so this is a very brief about the spatial microphones, because uh, in examination they have not asked regarding with these special microphone types, but still you must know the basic concepts of each microphone. Okay, sorry, what happened? Okay, then coming to the loudspeakers. Okay, so again the loudspeakers are having characteristics similar to that of microphones. Okay, so here we need to consider these characteristics. The first one is directivity. The microphone is having directivity pattern in the similar manner. The speaker is also loudspeaker is also having the directivity pattern. Okay, so in our practicals there is one of the experiment in which we supposed to calculate the directivity pattern of the microphone as well as the speaker. Okay, so what you need to do is you need to put some source before the microphone, and you have to rotate the microphone along with the circle, that is 360 0 to 360 degrees. Okay, and while rotating you have to calculate the output power produced by the microphone, and that you have to plot on directivity graph, so that you can get the directivity pattern of the microphone. And similar we are performing, we are keeping the microphone steady, and we are rotating the speaker throughout 0 to 360 direction, and we plot the values of output power on the directivity graph, so that we can get the directivity pattern of the loudspeaker. Okay, the second parameter is signal to noise ratio, the efficiency of the loudspeaker, the frequency response, distortion, the coil impedance, the coil which is used in the loudspeakers, and the power handling capacity. Okay, so all these are the characteristics of the loudspeaker. Okay, so most of the loudspeakers are not omnidirectional. Okay, the practical loudspeakers are directional. That is why in PA system installation what we have seen is you have to install the speakers at various heights and various orientations. Am I right? So directivity is the ratio of the sound sensitivity due to the practical speaker at a point in the direction of maximum intensity to the sound intensity. Okay, at the same point due to an omnidirectional speaker. Okay, the, the signal to noise ratio. Okay, which indicates the noise contributed by the loudspeaker. Okay, so it is defined as ratio of signal output to the output noise of the speaker in absence of the signal. Okay, so signal to noise ratio must be as high as possible for the loudspeakers, same that of microphone. Okay, the speaker efficiency is defined as the ratio of the sound output power of the speaker to the electrical power applied to its input. Okay, so the efficiency is measured at a standard frequency. Okay, basically 400 hertz is used to measure the efficiency of the speaker. Okay, so the efficiency can be improved if mechanical impedance is matched properly with the acoustic impedance of the air volume being disturbed. Okay, then the frequency response. Okay, so frequency response is a plot of loudspeaker output for different frequency signals applied to its input. Okay, so ideally speaker output should be same irrespective of all the frequencies. Okay, that is, the frequency response should be flat over entire audio frequency range. Okay, from 20 hertz to 20 kilohertz. Okay, then the distortion. Okay, the non-uniform magnetic field in which the speaker coil moves is responsible for producing non-linear distortion. Okay, the frequency and phase distortion may take place as a result of mass and compliance effect. Okay, so that could be as minimum as possible. Okay, and coming to the coil impedance, the input impedance of the loudspeaker should be matched with the output impedance of the driving amplifier to ensure maximum power transfer, as we have seen earlier. The typical values of the speaker impedances are 2 ohms, 4 ohms, 8 ohms, and 16 ohms. Okay, so in our practicals also, in PA system kit, there is a provision to select the speaker impedance with reference to the values like 2, 4, 8, and 16 ohm. Okay, the maximum power handling capacity. Okay, coming to the maximum power handling capacity, the power applied to the speaker should never be greater than maximum power handling capacity to avoid the further damages. Okay, so these are some of the characteristics and their details. Now coming to the types of loudspeaker, they are basically classified into three main categories. The first one is moving coil or cone type. The second one is electrodynamic type, and third one is horn type. Okay, so let us see a brief review of these microphones with reference to principle of operation and characteristics. Okay, so coming to this moving type, moving coil type or cone type. Okay, so the principle of operation of the speaker is same as that of electric motor. A voice coil is placed in a uniform magnetic field produced by the permanent magnet. When the audio signal or audio current passes through the voice coil, okay, an interaction takes place between the magnetic field and voice coil. So same principle that we are looking since, okay, since our first year. Okay, the basic electrical engineering, from basic electrical engineering. Okay, so when the audio current passes through the voice coil, an interaction takes place between the magnetic field and current through the coil, right? This interaction produces a force that works on the voice coil. Okay, due to this force, the voice coil vibrates, which makes the conical paper diaphragm to vibrate. Okay, so there's a diaphragm which is being vibrated due to this force. This produces the sound waves in the surrounding air. The moving coil loudspeaker consists of a voice coil. It is a single layer winding wound on a cardboard or fiber cylinder. The audio frequency current is applied to this coil through its contacts. A pot type of permanent magnetic is used to develop a strong radial magnetic field. The shape of the magnet is such that it produces a strong magnetic flux in the air gap where the voice coil is suspended. Okay, the coil is attached to a conical paper diaphragm. The paper cone is having circular projections. Okay, and this in because this increases the surface area of that particular diaphragm. Okay, when you are coming to the electrodynamic loudspeaker. Okay, so the diagram is as shown in the figure. The construction of, please mute your systems so that others can listen properly. Tejaswini Karche, please mute your system. Okay. Now coming to the electrodynamic, the construction is very similar to that of cone type of loudspeaker, except for one difference. Okay, the permanent magnet here, okay, has been replaced by electromagnet. Okay, only there is a difference. We are using electromagnet over here. So this is done in order to increase the strength of the magnetic field for high wattage speaker. I'll again repeat, all the participants should mute your microphone. Okay, so what I was saying, okay, so instead of permanent magnet we are using electromagnet inside electrodynamic loudspeaker. Okay, so the working principle is same as that of permanent magnet type, only the thing is that we are using the electromagnet, okay, instead of permanent magnet. The next type is horn type. But before going to the horn type, okay, let us have a basic differentiation here. In we have to create uh, different supply for the permanent, sorry, electromagnet, so that whenever there is a presence of sound, okay, it will act as a the force which produces or which moves the coil, okay, to create the sound effect at the output. The final thing is horn type loudspeaker. Okay, so the construction is as shown in the figure. There are the constituents of this one. Okay, the horn is tapered enclosure. Okay, it has two ends called throat and the mouth. Here, the throat and the mouth. Still, some participants have not muted their sound. Okay, let it be. The diameter of the horn increases from the throat to mouth, as you can see in this diagram. So basically, you might have seen such, loudspeakers. Okay, the horn thus forms the air chamber between its two ends. Okay, the operation of the drive unit is identical to that of the paper cone type speaker. Okay, as we have discussed earlier. However, here, instead of radiating the acoustic power directly into the open space, it is first delivered into the air chamber of the horn. Okay, so in this way, the horn type speakers are indirectly radiating loudspeakers. Okay, the horn speakers acting like a coupling device between diaphragm and the open space. Okay, so due to the presence of horn acting as an acoustic transformer, a better impedance matching between the low impedance of the free air and the high impedance of the voice coil assembly is achieved. Okay. So basically it is having, you know, the frequency that can be produced by horn is given as f minimum is equals to 170 divided. Something happened. Let us wait. I'll again reshare the contents. Okay. So here f minimum is given as 170 divided by dm. Okay. So where dm is diameter of the mouth in meters. Okay. So likewise, with reference to the diameter of the mouth, you can calculate the frequency that can be produced by the horn. Okay. So this is a very brief description about the types of various loudspeakers. Also, there are various types of the special purpose loudspeakers like piezoelectric, okay, electrostatic, plasma, and digital. Okay, so here also you need to consider some of the parameters for the comparison of loudspeakers like principle of operation. Okay, so what is the principle of operation for all loudspeakers? When a current carrying conductor is placed in a magnetic field, it experiences a force, and this is the common principle used in all type of loudspeakers. I'll again repeat the principle of operation of the loudspeaker as when a current carrying conductor is placed in a magnetic field, it experiences the forces. Okay. Then the directivity. Okay. So basically, most of the loudspeakers are covering the wide range of angles of the directivity of there, but for that purpose they have to be enclosed, uh, or they can be used directional by using the buffers and the enclosures. Okay, so you can see that the speakers loudspeakers are coming within an enclosed surface. Okay, so that makes the loudspeakers directional. Okay, then you need to compare the efficiency, the frequency response, the distortion, the impedances, okay, power handling capacity, okay, radiation of sound, impedance matching, the size, and so on. Okay, then coming to the next important concepts that, okay, why do we need the baffles and enclosures? Okay, so here you can see a type of enclosure. Okay, so why do loudspeaker need enclosure? Okay, so the truth is that speaker do not absolutely require the enclosure to act as a transducer, but nearly all utilized enclosure to improve the performance. Okay, so basically the speaker enclosures have a great effect on the speaker's sonic characters. Okay, and are largely required to migrate the phase cancellation at lower frequencies, because what happens, uh, if you test a particular loudspeaker without enclosure and with enclosure, you can feel the difference. Okay, so basically the baffles and enclosures are used. Okay, so what do we mean by baffles? Let me write it down. Baffles. Baffles. Okay, it is a rigid flat material which is used for extension of the edges of the loudspeaker cone, is known as baffle. Okay, so what is the necessity why we use baffles? Okay, when the cone of the speaker vibrates, okay, it radiates the sound energy in all directions, including front and back sides of the cone, right? So when the cone moves forward, the air is compressed in the front, okay, but the rarefication takes place at the back, right? So when the cone moves backwards, the compression takes place in the back and rarefication occurs at the front, okay. Thus the sound waves produced on the front and back sides are 180-degree out of phase, okay. So due to absence of the enclosure or baffle, what happens, the sound waves produced, okay, on the front and back of the cone are 180-degree out of phase, right? The sound waves from the back will leak, okay, around the sides and meet with the sound waves on the front side. If the path difference is small as compared to lambda by 2, then two waves will be out of phase, right, and cancel each other's, okay. So this cancellation is severe at low operating frequency, right? So the baffles are used to avoid this type of cancellations of waves, okay. So basically what happens if you keep open without baffles, what happens, the sound coming at the front and sound moving uh, at the rear side of the cone, okay, what happens, they becomes out of phase and cancels each other, okay. So as to protect that, we use the baffles, okay. So what are the types of baffles? Finite baffles, infinite baffles, enclosures, and bass reflex baffles. Okay, so these are the four types of the baffles. Okay, basically, in woofers, okay, you have seen that the sound is coming from one direction and the force is coming from the other direction, right? So it has been enclosed to have the proper setting of the directivity of that particular woofers, right? So these baffles and enclosures are needed so as to enhance or improve the performance of the loudspeaker. Okay, so I'll share some content in which you can see on the proper structuring and some technicalities regarding with the baffles and enclosures in more details. Okay, so there is another concept which is called as multi-speaker system. Okay, so you can use of various types of loudspeakers for various purposes, but still so as to enhance or the quality of the sound, okay, what you need to do is you can have woofer, you can have mid-range speakers and the tweeters, okay, so that the the sound within the frequency range of 20 hertz to 20 kilohertz should be listened properly, because what happens if we don't have such categorization, okay, all the frequencies are coming through the only one speaker, right, and then we cannot have that much the feel of music, particularly music, okay. So we are having woofers, mid-range speakers and tweeters, okay. So what do you mean by woofers? Woofers are the low frequency speaker which are designed to produce only the low frequency sound, typically within the range of 40 hertz to 1 kilohertz, okay. So you can listen, see in your mobile phones there is a graphic equalizer, am I right? And on that equalizer you are having various frequencies. For example, let me draw a rough you know representation of that graphic equalizer. Here you are having various frequencies, f1, f2, f3, f4, 5, f6, and there are various you know levels. So if you increase this, you can get the effect or the presence of that particular frequency more in that particular audio. For example, if you lower the frequency, then you can get the sound of a drums, okay, octopads and so on. And here in between the high frequencies, you can get the sound of the acoustic guitars or electric guitars. Okay, so those instruments which produces the high frequencies will be emphasized more on the audio that you are listening. And in between these, okay, so you can listen to the vocals and the instruments which are producing mid frequency range. Okay, so the effect can be enhanced, okay, as per the requirements of the listener. Okay, so basically the woofer is intended to reproduce the low frequency sounds typically within the range of 40 to 1 kilohertz. Okay, then there is a second type, mid-range speakers. Okay, so those are designed to reproduce the sound in the mid frequency range, that is 300 hertz to 5 kilohertz. Okay, so that can be of cone type or dome type of speakers in the multi speaker system. And finally we are having the tweeters. Okay, so basically tweeters are the speakers, okay, for high frequency. Basically those are called as high frequency speakers, okay, which are designed to produce the high frequency sounds typically within the range of 2 kilohertz to 20 kilohertz. Okay, so basically the size, if you compare, okay, right from the woofer, uh, then mid-range speaker and tweeter, it basically decreases. Okay, so there are some of the types of the tweeters like cone type, dome type, piezo type, ribbon type, planar magnet type, electrostatic type, horn type, and plasma type. Okay, so if I just want to draw the frequency response of the multi-speaker system, okay, so I'll get the response like this. So this is your output in dB, okay, and this is your frequency, okay, right from 0 to 20 kilohertz. Okay, and here I am having, this is one response, okay, this is another response, and this is another response. Okay, so this is in regard with, sorry, this is in regard with woofer. Okay, this is for mid range speakers, and these are for tweeters. Okay, so you can see the frequency response like this. Okay, and the intersection here at 500 hertz and here at 5 kilohertz. Okay, so this is how the frequency response of a multi speaker looks like. Okay, so if you try to compare the components of the multi speaker system, that is woofer, mid range speaker, and tweeter. Okay, so the frequency ranges for woofer 40 to 1 kilohertz, 40 hertz to 1 kilohertz, mid range 1 kilohertz to 5 kilohertz, and tweeters 5 kilohertz to 20 kilohertz. But the sizes, okay, as compared to the size, woofer is having large size, mid range speakers are having mid range size, and the tweeters are having the smallest size. Okay, so how do we place these three components in the multi-speaker system? Okay, so woofer is generally preferred at the lowest position. Okay, mid-range speakers are kept in at the mid position, center position, and tweeters are kept at the top. So if you try to have the look of multi-speaker system, you are having this as a woofer, okay, this as a mid-range speaker, and you can have the tweeters like this. Okay, so this is basically for low frequency, this is for mid frequency, and these are for high frequency. You can have two or only single tweeter can be placed for the multi-speaker system. Okay, so this is how the speaker looks like with reference to the woofer, mid-range speakers and tweeters. Okay, so what is the attenuation? Okay, it is high for woofer, okay, moderate for mid-range and low for the tweeter. Okay, so application, the application is used for the music systems, home theaters and so on. Okay, so this is how this multi-speaker system looks like. Okay, then in most of the functions you might have seen, the loudspeaker columns. Okay, so loudspeaker columns are having a feed point common feed point, and there is a range of such loudspeakers connected in an array. In most of the functions you might have seen such arrangement of the speakers within an enclosure, and the common point is connected to all the speakers. Okay, so that you can have the sound effect, a larger sound amplification from the loudspeaker columns. Okay, so you need to focus on the amplification factor, then impedance matching and so on when you are dealing with such a loudspeaker column or loudspeaker array. Okay, then coming to the next topic, that is digital radio receiver. Okay. So digital radio can be defined as the radio which is using digital technology for the transmission or the reception of the signals in the radio spectrum. Okay. So what are the various types? Okay. So in one type, okay, the most common meaning of the digital radio system is digital radio broadcasting technology. This system converts analog audio signals into digital, okay, by ADC. The digitized audio is compressed using various formats, okay, and then they are transmitted. Okay, the objectives of this digital radio system are to increase the number of channels or stations in the given spectrum, to ensure a better audio quality, to reduce signal fading problem for the mobile users, to incorporate new data casting service, to reduce transmission power without affecting the quality, to increase the coverage area. Because what happens, if we are considering an example of FM transmitter, okay, in a particular city, if you are having the FM broadcasting at that time, there are certain limitations. Okay, so in you know in some places in the city you cannot be able to listen to the radio signals, okay, properly. Also, there are limitations of area within which the FM signals are broadcasted. Okay, so what we are doing is we are basically having the digitization of that particular radio signals or radio channels. Okay, because what happens, the digitization allows you to enhance the quality. Okay, how we can enhance the quality of the digital data? Okay, because we are having various techniques which requires less effort. Okay, for the digital signals. Am I right? Because in various lectures we have discussed about why we are moving to digital. Okay, because the filtration process, the amplification process, the transmission process, all these things are quite easy when you are dealing with the digital signals as compared to analog signals. Okay, so these are the main advantages of converting analog signal into digital. That is why we are having this digital radio broadcasting. Okay, the second type is wireless digital systems. Okay, so these are using radio system uses wireless digital technologies. Okay, accommodated on the radio frequency communication. And third one is system based on digital signal processing. Okay, so all these things are to be considered. Okay, the digital radio broadcasting standard can provide two services, basically two services. The first one is terrestrial service, and second one is the satellite radio service. Okay, so digital radio broadcasting systems are designed to provide the services, okay, to the mobile devices. Okay, basically could be able to listen the radio on your mobile phones, right? Some digital radio system provide in-band on-channel IBOC solutions which can coexist with the FM and AM systems. Okay. In some digital radio systems, a wideband radio signal is used for carrying several radio channels at different bit rates and data services and other media types in a multiplexed manner. Okay, so that could be the possible solution for that. Some system makes use of single frequency network, SFN we generally call it as, in which all the transmitters in one region which transmit the same multiplex signal may use the same frequency without interference to each other. Okay, and the major advantage is this will improve the spectral efficiency of the system, because as we have seen earlier is the most costliest thing is one of the most costliest thing is the frequency. Okay, so it is our art, okay, that how we can accommodate a large number of data within a given spectrum. Am I right? So you can utilize that for the accommodation of various signals within a given band. Okay, digital broadcasting has many possible advantages, but its introduction in practical use has been entered because there is no agreement globally on one standard. Okay, so basically uh, we are having some of the digital audio broadcasting systems, okay, like DAB, ISDB, TSB, internet radio, and so on. Okay, and we are also having the standards as follows. Okay, the number one standard is FM band on channel, FM band in band on channel. Okay, so it is basically HD radio. Okay, OFDM modulation technique is used over FM and AM band. The digital radio mandible extension. Okay, here the OFDM modulation technique is used over AM band. The second type is AM band in band on band channel, AM IBOC, which is used for HD radio as well as digital radio. The third one is the satellite radio. Okay, so there are certain applications. Here on your screen you can see the digital radio receiver block diagram. Okay, so here the digital radio receiver will have the features like crystal clear sound. Okay, plenty of the stations, okay, with surround sound, on demand radio, okay, recording facilities, okay, and so on, right? So the analog front end on the input side of the digital radio receiver, okay, it has been built around a high speed analog to digital converter. The input signal captured by an antenna is applied to low noise amplifier, okay, as you can see right here, okay. The LNA is a frequency synthesizer that generates a local oscillator signal and high speed operational amplifier as a part of AFE, okay. The LNA amplifies the analog RF signal from the antenna. This signal is then mixed with the local oscillator signal produced by the frequency synthesizer, and IF signal is produced, okay. So this is an analog IF signal, okay. Then high speed ADC block converts this analog IF signal into digital form, okay. A digital down converter is required in order to reduce the frequency of the ADC output so as to match with the speed of your processor, DSP processor, or the controller, right? The audio input and audio output are handled by audio codec, okay. So audio codec is also equally important to convert that particular digital data of the respective sound. Audio line in the input and radio signal produced by the DSP, okay, are applied to audio codec. The audio codec consists of digital to analog converters, which converts the digital radio signal processed by the digital signal processor back to analog form and applied to the audio amplifier, which drives the loudspeakers, okay. The audio amplifier here typically are of class D type, which is having very high conversion efficiency and very low harmonic distortion, okay. So due to improved power efficiency, the size, the weight and heat produced by audio amplifier is reduced at a greater extent, right? The power. So this is how we are converting the digital, the signals from the radio to digital signals, and again for listening, converting them into analog. Okay, the same thing is used for satellite radio reception. Okay, the satellite radio is a radio broadcasting service from the satellite. The satellite is broadcasting signals, okay, nationwide, which covers a larger geographical area, because the terrestrial area has got the limitation uh, for the broadcasting. Up to certain distance it can cover the area, but satellite signals can cover larger geographical area, okay. The satellite radio service is intended to be used by various users, okay, and it has got uh, several advantages, right? The thing is that what frequency band is used for the satellite uh, radio reception, okay. So 2.3 gigahertz, okay, basically it is a S band, okay, used for satellite radio service, okay. In most of the parts, uh, one can use 1.4 gigahertz that falls within L band, okay, which is basically allocated for DAB, that is digital audio broadcast, okay. The thing is that the subscriber of the satellite radio receivers, okay, purchase a receiver and pay for a subscription, okay. So basically it is a paid service, right? The programs of the satellite radio can be listened with the help of built-in portable receivers. Okay, so it is like, as we have seen, it is like a video on demand. Okay, so for that purpose you have to pay, and you can select any video that you want to see. In the same context you have to pay, and you can get all the channels worldwide, okay, broadcasted to your satellite radio receiver. Okay, so the uh, in operation, the ground station antennas transmits all radio stations to a geostationary satellite, right? The satellite receives the signals and regenerates them and transmits them back to the downlink with the downlink frequency to the radio receivers. Okay, the radio receivers will first unscramble the received signal. Okay, so basically these signals are encrypted and scrambled signals. Okay, like we are having various service providers for our television, like Tata Sky is there, Airtel is there. Okay, so if you just get the wire, okay, from someone's antenna, and if you plug in, you cannot be able to visualize that because all the signals are encrypted, because it is a paid service. On the similar manner, we are also having this satellite radio reception. Okay, so the radio receivers will first unscramble the received signal to display the broadcast information. In certain systems, ground receptors make the satellite signal available even when the satellite signal is blocked. Okay, satellite radio service can provide nationwide coverage. Okay, and the examples of the satellite radio is XM satellite radio, Sirius satellite radio, word space radio, and so on. Okay, basically, a few days back, AR Rahman was advertising this word space radio. Am I right? So this is a kind of the same thing that we are experiencing in regard to the DTH services. Okay, only the thing is that instead of video channel, you are getting all the radio channels worldwide. Okay, based upon your subscription and so on, and you can listen to all the channels at your home. Okay, so this is the basic concept of the satellite radio. Okay, so when we are comparing the AM FM services, okay, satellite radio services and digital television radio services, okay, so AM FM are completely free, but when you are comparing the satellite radio and DTR, they are paid services. Okay, so the portability, the coverage, the quality of reception, the variety of program, okay, then interruption due to commercials and government regulations. Okay, satellite the paid services plays quite better, because if you take an example of paid subscription of YouTube, then you need not to worry about the ads. Am I right? Okay, if you are watching YouTube for free, then when you click for a certain video, then you have to listen to the ads, which may extend up to 5 seconds to 25 seconds. Okay, so that happens generally. Okay, so the paid services are quite good. Okay, due to that you are getting a very good quality and the faithful signal, along with the uh, you know reliable services. Okay, so this is how. So don't worry, I'll share all the diagrams with you. Okay, so let- someone has been requested to annotate. Okay, let it be. So this is for the sixth unit, and somehow we have covered all the aspects of sixth unit, and I will be uploading all the videos recorded in the lockdown period, okay, within 2 days, okay, and I will make you available all the videos through the Google Classroom, okay.